Thanks everybody for coming out on this evening. I'm going to try and pick up the pace a little bit and start talking about this concept of evolutionary or agile database design. A lot of people, when I talk about this topic, get a little bit antsy. There's a lot of things that I'm going to cover today that I just think are good practice. So even if you don't want to practice agile database development, or agile evolutionary database development, a lot of what we're going to cover is just good practice. All right. So who am I? All right, so as Stephen's introduced me a little bit, I'm Chris Tite. I work at Cloudicode as a senior architect. Have worked on quite a number of applications and quite large solutions. I think we've seen a lot of things out in the industry. And this is one of my pet topics that I think it's an important aspect for us to cover. So I'd really like us to talk about it. If you don't know already, all my talks are driven by beer. So at the end of the Q&A session, I ask if you guys could keep your questions to the end. Q&A session, I've got 6 beers here to give away to anybody with a challenging question or an interesting response or some sort of opinion that maybe is not responded to that well, but is interesting. And if you don't drink beers, I've got some chocolates here for the non-beer drinking guys. All right. So I want to start off this talk by telling you a story. Why did I suddenly decide I wanted to actually do this talk? And it started with a lady called Esther. Now, Esther was a project manager at ABSA. And we were upgrading their software. Now, we used to write banking solutions for ABSA. And it was one of the biggest solutions that we actually had to maintain. It managed about 2 billion rands worth of transactions. So it was a big database. Had quite a lot of integration points on it. It had quite a large number of different services that were running on the system. And the reason why I raise this as a database problem is because every time I do this talk, every time I talk to somebody about this, they go, oh, you can't do this. Our databases are way too big. So the reason why I raised the 2 billion thing is because I've seen millions of transactions. I've seen hundreds of millions of transactions. And the techniques that I'm going to cover tonight are actually quite trivial to be able to put inside this type of, inside big systems as well. So we'll talk a little bit about that. But I want to assure you that it's not just small database systems that we're going to be talking about. Now, the reason why I raised Esther is because Esther came in one day with a project. Now, if you're in a banking project, you get one chance to do a release. One chance every 3 months. You've probably got about 2 hours to get that thing done. If you don't get it out, you don't get paid. And you may not get it out in the next release because the release coming up next, everybody else has been fighting to get your project in there. So it's really important that you get these releases out. And Esther knew this. Esther came walking in on a release day, Saturday morning, carrying a picnic basket. She was that prepared to spend her whole day waiting for this dev team to walk in. So Esther walked in, she set out her picnic basket and she said, can I get anybody some coffee? And we said, Esther, it'd be really good if you could get us some coffee. And off she trotted to get us some coffee. And the network engineer now set up, ran our database scripts, database up to date, ran the database, the code release, code up to date. And Esther came trotting back with a coffee. And I said to her, Esther, we're done. And she said, okay, cool. So when normally you're ready to get started. And I said, no, Esther, we're done. Can you phone the user and can you get the system ready to go? Literally, in the time it took her to get a cup of coffee, it took us that same time to take our system from version 2.0 to version 4.4, database scripts. There was 2 years worth of work. Database scripts up, ready to run, everything out. And that was it. So it's one of the reasons why I get so excited when I talk about this particular topic. Esther could have kissed me. She had a whole day of shopping planned now. Her whole day had changed. No more picnics. She could actually go out and do some shopping. She'd outsourced the kids, husband was out, and so she could spend her day shopping. So it's an interesting story, and I hope that story sticks with you in terms of what can be done when you start putting some of these practices in place. So as I said when I started, and when I do this talk, I get this kind of look, this kind of insane person at play, straitjacket, please don't come near us, this is not such a good idea. But I stand by it. What I'm going to teach you today is repeatable. So it doesn't matter what server you run this on, it's always repeatable. Hands up, anybody who's worked on a project with 5 people and everybody's copying the version of the database from one server to the other. Your database DBAs are using SQL Delta to bring your databases up to date. And there are probably 5 or 6 SQL Delta scripts to try and bring your database scripts up to date. Big problem. It is a real issue. But what we're going to talk about today is a repeatable process. It's reliable. I can run it on A's machine, I can run it on B's machine, and it happens all the time. It will just work because it works. And it's scalable. It doesn't matter how many people I'm working on my team. I can have 2 people working on the team. I can have 20 people working on my team. And the practices we're going to talk about now are good practices because everybody's database can be brought up to date with a minimum of fuss. All right, so what is evolutionary database design? So I'm going to introduce you to a system. It's just basically a system where I'm going to place some order items, and that's just a simple order system. That was version 1 of my software. And then at some point in the future, somebody's going to ask me to be able to bring some suppliers on. So in version 1.1 of the system, we start supporting suppliers. In version 1.2 of the system, we start putting some of our orders on back order. And then on version 3, or version 2 of the system, somebody says, well, we're going to actually allow somebody to log in from the internet. All right, so we've got a system that's evolving over time. In the old days of database design, we designed the database. My very first project was a geographic location system for Rennies. And they had spent R1 million, and R1 million in 1994 was a lot of money. They had just spent R1 million getting the ERD designed. That was it. Started up just doing the database design. And thou shalt not veer from this database design. Those days are gone. We don't design systems like that anymore. We design systems like that. We design systems where we start with the concept, where we start taking it further, and we start taking it further. And we need a practice to be able to manage this system as we evolve our database from one version of our software to the next. The important thing to notice is that database is also code. It's part of what we're actually doing. And so the database artifacts need to be treated as such. And we're going to talk about how we treat them as code. So here's some strategies. The idea is to script all the changes to our databases. And I know this sounds quite trivial, but it's something that we never, ever, ever practice. Well, that's unless you work on the team with me, in which case it's drummed into you. All changes are scripted. If you're changing the data type on your column, it's a script. If you're introducing a new table, it's a script. If you're introducing a new column on a table, it's a script. If you're moving data from one place to the other, it's a script. And all of those scripts are checked into source code control. Right, so anybody can get hold of them. And we've got a history of what we're actually doing. The scripting starts at day 1. The scripting starts with create database. We have to set up the database. Where is it going to go? How's it going to go? It will then create the initial tables. And basically, that's where we go. Sprint by sprint, the database is moving from one point to the other. All right, so we're scripting all the changes. Very small, microscopic changes. Every small change, introduce a table, that's one script. Introduce another table, that's another script. All right, so we're starting to follow where we're going. The smaller the steps, the easier it is to apply. And you need to take this to heart. When you see the SQL Delta come out and it's a 3 meg SQL script, that's not a very easy script to debug. It's not an easy script to roll back. It's a nightmare. It's actually very, very, very difficult. So the idea is to take your scripts and make them small as possible and just keep rolling them forward and keep rolling them forward. So we break large changes into small steps. And on the next slide, we'll take a look at what I mean by breaking large changes into small steps. We choose a suitable deprecation period. Now, on small systems, where the system's still growing, you don't need to worry about this. But on very large systems, you've got to have a system A and a system B and a system C trying to connect into your database. And B and C might be within your control, so you can actually bring them up to date quite quickly, but C may not be. So you need to choose a period over which time you're going to start making these changes. And sometimes, as we'll see in the next one, we actually have to keep 2 versions of the data. I know it's denormalized, I know it doesn't work, but this is a way to keep our sanity within our database. How many people have a database system where there are tables which you have no clue what they do? How many have got that one table? It's the one table. It's got probably 18, 19, 20 columns on it, and there's 2 columns that you still use. The rest are dead. And then people start to wonder why the database performance is pretty crappy because you've got to maintain this extra database, you've got to maintain extra indexes. It's a problem. We also need to choose some sort of suitable synchronization strategy. Sometimes we have data on both ends of the system which we're going to start moving, and this will make more sense when we get on to the next slide. But there needs to be a way to be able to synchronize our data and keep this denormalized situation under control. So let's take a look at an actual practical example. What I'm going to show you here is a simple refactor. Well, it's actually not that simple a refactor because it's probably one of the more complex refactors. A simple refactor would have been just introduce a new column on a table, or rename a column on a table, or just create a whole new table, or rename a table. Those are simple refactors inside our database. This is going to be a slightly more complex refactor, and just to give you a flavor as to what's actually happening and how we work it. We started off our system by having a user and an employee. And in our system, we had users that could log on to the system, and users were employees. They were one in the same thing. And at some point, somebody said to us, well, employee doesn't necessarily have to log on to the system, so we're going to expand it a little bit. So user doesn't necessarily have to have a one-to-one link. We'll have a one-to-one link, but we can have more employees in the system than we have users. And then somebody said, I need to be able to change the email address. But I need to do it for my whole system. I don't need to do it for just the users inside my system. So when we started designing the system, we had perfectly logical username, password hash, last login date, and an email address on my user table. And my employee table was just a name and surname. All right, it probably had some more ancillary data in there, but we don't really need that for the purpose of this demo. You'll also notice that I had two systems, System A and System B, connecting to the system. They were both using those particular pieces of data. And the decision was made by the development team to be able to move the email address to the employee, because we need email for everybody in the system, not just our users. So the first refactor would have been introduce the column email onto the table employee. So that's the very first one. We would have written a script, would have been alter table, include column, and the column of type varchar string, or varchar 50, or whatever it is we decided to use. And we would also have kept email on that side. Now, in most systems, it's not going to be the problem because you don't have two systems looking at it, or both your systems can change, or if these two systems were both within your control, you could change those pieces of code. Sometimes they're not. Sometimes you've written an API, or you've written some kind of interface that somebody else is using, and it's going to take a bit longer for their code to be able to change. You might have a legacy system. There's a whole heap of reasons why you need to be able to do that. In which case, you're now going to keep the email address on this side, and you're going to keep the email address on this side. You're also going to write a script that's going to move the data from this column to that column, so that you've now migrated your data. All right. At this point, if you were in your own system, that would have been the whole refactor. It would have been actually li. It would have been create email, move data, and then we would have dropped the column. But because we've got the system here and the system here, which can't be updated, we bring in a trigger which will be able to bring in and move the data across from one side to the other. So that's where I talked about the suitable synchronization process. So your system is denormalized, and in order to live with that denormalization, we start introducing the concept of triggers. We might be able to have the web service add to both sides for some reason. There are a number of things that you can do, but just to show you how you can leverage some of these techniques. And then at some point, we would drop off the email address from that point. And that could be 6 months from now. It could be a year from now. We'd also drop off that trigger, and now the system is stable. But as you can see, you can actually do it in one fell swoop because your system's a very small system, or you could do it in a very, very long protracted period because your system is quite a large system. All right. The reason why I raise this is because a lot of people say, well, we can't do it, and I don't like denormalization. I don't have the tools. The tools are right there. There are just different ways to think about it. Sometimes you want to rename this column or this table. We often have this case where we want to be able to rename a table because we follow a domain-driven design principle, and even our database speaks to the domain. And all of a sudden, somebody doesn't call an employee an employee, they call him a minion. That's what they decided. Somebody decided to call them minions, and if there are minions in our vocabulary, then they need to be millions inside our database as well. And so we need that refactor. So some systems would still be looking for an employee. Well, you can wrap that in a view. You can still see that information. there are techniques that are available to be able to start working with data that doesn't travel very easily over time. All right, so some more strategies and more information about what we do. The way we manage this is that we actually version up our databases. So every single version of our database carries a schema version, right? And it's just a simple major release, minor release, sprint, and iteration release. So any major version that we're working on, any minor version, that you can choose as to how you want it to go. Whatever sprint we were working on, this is the sprint here. This is what take you from this version to this version. And any iteration releases, those are if things were buggy in QA, then we would be able to increment those things. So we do version up our schemas. All right. We uniquely identify every single change. We'll have a look at this when we start looking at an example of what the files look like. And there's different ways that you can uniquely identify every single one of these scripts. So if you remember, we're going to have a script for every single change. And I'll show you just now what it starts looking like in Sprint 1, which is we'll have a look at one of our projects for developers, and 2-week sprint. And you can see there are a truckload of scripts that come out. They need to be uniquely identified. And for one reason, they need to be chronologically run. So if a developer did this on this day, and then a change on the next day, you need day 1s to run, and then days 2 to run in that chronological order. And the way we do this is to either give the scripts a unique number, so you can have a unique number generator inside your organization that says this is script 1, this is script 2, this is script 3, this is script 4. Other techniques might be you can name it whatever you like, but then you have a metadata file that tells you in what order these scripts need to run. I find that quite frustrating to work with because it means I've got to be thinking about 2 places and where I have to run. What we found the simplest way is to actually date timestamp them. So you just take the year, 2014, take the month, 09, take the day, 16th, take the time, 10/00, and you now have a perfectly chronologically ordered set of script files. Put in a little name to describe exactly what it is so that nobody's trying to scratch their head going, I just see numbers and I don't understand what I'm doing. And that's how we version up our script files. We'll have a look at what those look like when we do a bit of a demo. All right, what we also do is we include configuration tables. So again, we include a table which will give us what our schema versions are. And then we also give a table which gives us a change log. So we know exactly what scripts have been run on our database. Every single database has a change log inside it and say, this is run, this is run, this is run, this is run. You need that because if somebody's just run your database upgrade, and it's normally just an IT body who goes run the database upgrade, you need to be, if something's failed, you need to be able to go back and actually have a look and see what on earth it is that failed. So change logs are always important. We'll have a look at that. One of the other things that I've picked up that quite a number of teams started doing is to actually make your scripts idempotent. So what this means is that you can run the same script twice without having the effect. Well, the script runs once and does the change, but if it runs again, it doesn't try and affect the same change. Those scripts become a little bit more difficult to maintain because you've got to be checking, check first, did you add the column? If the column is on the table, then run the script. Otherwise, don't. Depending on your team, those might be difficult or they might be easy to run. But if you can make them idempotent, it's so much more of a safety net because somebody can run the same script 3 times and it doesn't actually change the schema of your database. All right, so we're going to talk a little bit more. I talked a little bit about domain-driven design principles in that because you're now evolving your database, because your database can now keep up with your language, you're no longer left with something that was called a loan but is now called a contract that is now called something else. It actually, your database domain speaks to your actual domain of your system. And that's important, especially if you're doing domain-driven design. It's also important to be able to easily set up the databases. So what I often find is that somebody's news on the team, they don't have a version of the database, or you can't get hold of a live database. You go to a banking system and you ask your client for a live database, they're going to laugh at you. I mean, that's just ludicrous. I mean, it must be mad. So be able to easily set it up, and that's one of the things that we're going to get out of this, is a technique to easily set up a database. all my database changes are under source code control. So when my database changes, there's no question about who changed it, why they changed it, when they changed it. It's in source code control. I just pull them back out again. I run the scripts, and that's it. There's no, oh, did you run the SQL Delta? Have you got the latest version? Oh, I emailed it to you. No, it's none of that crap. It's inside the source code control. Once a script is committed, and this is the reason why I'd raise this is because it's a real problem on the teams that we work with when they first try and do these techniques, is once a script is committed, you cannot go back in and change it. All right, when you print a document off the internet, the document is no longer valid. You need to know that. It's the same concept as when you run a script or you commit your script. When you commit your script, you are done. If you needed to make a change, or if there's some weirdness that actually had to happen, if it's a simple change, well, you got to script it again. If you left a column off, you're scripting another column onto your table. You're not going back in there and changing it. If it is a colossal mess, it's then time for the team to scrum around, or to hive around, or get around the team table and go, okay, this is the script, how are we going to change it, who ran it, when did it run? But very few and far between. I think we've done it once or twice where a script has been that bad. Automate running your scripts. Okay, this is a pretty logical thing. So basically being able to take our database from one version to the other, be able to automate them. You don't want to be running every single script through Enterprise Damager, opening it up, running script, opening up the next running script. And you guys laugh, but in some of the banking teams that I've worked on, that's how they bring the database up to date. Okay, so we automate. We're going to look at a little bit later on automating your tools. There we go. Right, so what I'm going to demo to you now is just a little application we've brought out, and discussing it with Rory last night. I've done this talk at a couple of other companies, and every time they go, hey, cool, can we just get hold of the source code? So what we're going to do is we're going to find a GitHub project somewhere. We're going to put the source code out there, let everybody start playing with it, and start feeling the joy that we felt for the last, I don't know, 10 years? 10 years. So this concept and this program was born 10 years ago, and we've just taken it further in little steps. And every now and again, one of our junior developers goes, hey, I want this, or one of our senior developers wants this new feature in, and we start putting a new feature in. All right, so I'm going to show you DB Sync Master. All right, it's a bit of a cheesy name, but we love it. All right. Oh gosh, okay, so I'm just going to show you, I've set up a database to start running the system. It's a blank database, and I'm going to run the first set of scripts for one of the major projects that we worked on about 2 years ago. Inside our database, we have a DB version table, which basically keeps the schema version as it stands right now. And then we have a script log table, and that's the change of the log of all the scripts that we've basically been able to run. Incidentally, DB Sync Master uses that script log table to keep synchronized, so it knows which scripts have run and which haven't run. All right, so that's what the database looks like. There's DB Sync Master. I can choose which database server I want to connect to. So I'm just going to connect to my local machine. And there we go. So DB Sync Master is started up. And it's going to the last folder that I ran one, which I just did a quick test of this before I came in, so it's going right to the folder. And it's telling me which database I'm going to be running on, Agile Evolutionary databases. I can go and fill that in and change the database if I needed to. You can see here, from the start, creating the tables. You'll see lots of inserts of alter tables, and you'll see repeats. So we'll create a table and we'll alter a table, and we'll create a table and alter a table. If we scroll that down a little bit, you see there's a large number of those scripts. There's quite a few. All right. So the way you run DB Sync Master is to select all the scripts and execute. And that wasn't supposed to happen. Oh, okay. I know what happened. All right. So an interesting thing that came out. Oh, I know we're running from the wrong version. You'll see here that it errored, and the scripts normally get pulled off when they've been run. And what DB Sync Master does is actually keep everything inside a transaction. So it runs all of those things, and if something fails, it just goes, oh, forget everything, roll back. One of our senior developers has just actually put in a new feature that goes, I just want to test this. I want to test all of these things to make sure they all run. And that just starts a transaction scope, tests them all, and then just unwinds everything else that you've already done. All right, so the reason why this is failing is because I'm actually on version 1. and I should be on version 0. So just to give you an example, damn, okay, we go here. Sorry, the screen's a little small. So it's loaded up the latest set of scripts. I'm going to be running here. Run the scripts. And with any luck, they're all set to green. And you'll see they've moved from this point over here to that point over here. So successfully moved my database or created my database and set it up as 1.0, 1.1.0. All right, and then a demo which you've already seen. We're just going to quickly go and do the next version. All right, so 1.0. And I'm going to do the same update to my database. And you'll see it didn't run successfully because the database scripts haven't moved, and there's an alter table error. And essentially what I've got in, I've actually made a script problem in here, which I'm not going to go and change, but I really just wanted to demo that problem, that scripts hit a particular problem, and we've got alter business role table, and everything inside this system is then rolled back. Okay, so it's important to be able to have that type of functionality inside your system, because you don't want to half upgrade your database to a particular point and then, oh my goodness, we've got to try and back out. On some of the database systems that I've worked on, a back out could be a real problem. We can talk a little bit about scripting up and scripting down. I'll chat a little bit about that, but it's very difficult to try and implement that. But if you're going to back out of your system, some databases are, 2-3 hours before you've restored, and that's a real problem. So being able to put them in a transaction scope is very important. All right, so let's carry on, and I'm nearly done. All right, so that's DB Sync Master. What we've also done, we've created this little tool here, which I find quite handy. It's called Script Compiler. So essentially, it goes into all the little projects that Script Compilers look for, and it sniffs out all the scripts, and it brings them into one neat little folder, and it works with them, because when you do a lot of domain-driven design, everything's in its sort of domain compartment separation of concerns, and now you've got to remember who's done which database changes, and the communication's not always that great. It's best to be able to use something like this to be able to go and sniff them out. All right, so we've done a little bit of a talk. One of the other interesting things that, a lot of people ask me this question, so do you trust the system? Do you trust the way that you do it? And I'm going, yes, we trust it. We trust it implicitly. And one of the reasons why we do trust it is because we bring in a very stringent release process. All right, so we do all of our code, database is coded up here, put it onto our build server, code repository, and then we start the database release script, database release. And this goes into our integration testing area, owned by devs. Devs can do whatever they like on that type of system. They can put FJK into a name field. I don't care, all right? That's what the devs, it's your database, that's what you work on, and at that point over there is where they spend a lot of time making sure that these scripts are working correctly. What we then do is then move over scripts onto a QA server, and at QA server time, devs don't own the server anymore. No more FJ, QA owns that server, and QA will bust your butt if you don't move your data correctly, because QA are the first line of business support inside our organization. Because QA set up test packs, because QA own test packs, it's like their own data. And let me tell you, if a developer moves a column incorrectly or drops an entire table and then recreates it with nothing inside it, that's the first customer that starts complaining. Right, so we start fishing out all the other little errors over here. And the other thing that we do is we never allow a developer to release to QA, because developers are sneaky. Developers are always trying to jig the system. And they'll go, oh no, I forgot this script. I'll quickly run it through here and then run it to there. So we always get somebody who's got no vested interest to release to the server. And then by that stage, we're then moving to staging. And but once we're moving past this point, this is really, really solid. By the time we get to live, it's rock solid. All right. So how do I get started? So you're asking yourself, you're sitting there going, okay, cool, I've seen all this thing. You've shown me from a very, very blank database. How do you get started? Well, on a large number of brownfield projects, this is how we get started. We baseline the database. So you can get these tools, Redgate if you've got a lot of money, Apex if you've got a little less money, and then MS Tools if you are keen for a bit of an uphill grind, then you can find something that's a price point and a little level of effort that you want to go into. You can baseline your database with data and your schema. Set that up, and that's the version that you're actually going to run in. From that point on, well, we implement a bit of a release process so that you can manage these wild and woolly developers, and then you apply your evolutionary techniques. Every single sprint puts your database changes in place, and very small changes, as we've discussed, as you go. One thing I need to point out, when we first started this, it's 2005, I think, when we did this first implementation of these techniques, it's not easy. Developers don't like this. It takes a while, and one of the biggest problems that we've had on some of our development teams when we go into customers is that they hate it. It's very, very foreign, because it's normally just one guy looking after a database, and he doesn't think that there's 2 or 3 other people that need to get involved. So it's not easy. What we found is that it took 3 sprints, and at this stage we were doing 3-week sprints. It took us 3 sprints just to bed in the concept of getting it going. It took a couple of other sprints before the whole process was going. But I have never looked back after the days we started doing this. And I need to point out that senior staff hate this. I hate this. I've done this talk, I did this talk at a number of other companies, and the first people who put up their hands and say it's never going to work is always the senior. It's always that grizzled grey hair guy in the back is going, it's never going to work. It works, it just takes effort. I want to talk about some other options, because there are other options. And one of the things that I did talk about briefly was this change up and change down. So there are 2 parts to rolling out a database change. One is to do the change up. So what are you going to do to version up to the new, what script are you going to run to version up? And if that script fails, what script are you going to run to undo the changes? We generally don't do the undos. They're quite a lot of effort for something that we found we don't often have to do, because we've got a fairly rigid release process. The only time we've really had a problem was when a script took too long to run, and then we had to refactor the script a little bit so that it got a little bit better. But we haven't had a problem like that. So you can do it, but I think often it's a bit of wasted effort. It really also depends on how mission critical your systems are and what the uptime of your systems are. If you have no downtime, well, then you're going to have to start investing in the downside script. But if you've got an opportunity to run the script, something fails, you've got half an hour to recover or 2 hours to recover your database, then the extra effort is not worth it. All right, so that's just, it's an opinion. So some of the tools that have come out, Fluent Migrator is basically a set of classes that you can see use a class as migration, and when the system starts up, it says, okay, I can create a table of users with columns, and it goes and physically creates the table inside your code. So it's code creating your database and migrating your database from one version to the other. And you can see here they put a version number on, and you can version up and version down. And that's how they version down. I'm not particularly fond of it, because one of the things that I do find is that in very, very complex systems, I often need to get a DBA to start helping me with some of the scripts. And the DBAs don't like that kind of thing. All right, so we still tend to keep in the scripts and managing the scripts and doing it via script, because often we've got a DB person that needs to come in alongside us and help us, specifically when we're doing moves of data around a system. The other technique which we've started to play around with, which is Visual Studio database projects, which is basically Visual Studio, and I think of 2012 and now in 2013 has allowed you to create a database project, and you can refactor your database. You can rename a column, you can change the database table name, you can move a column from one side to the other, and they give you the script to be able to do that. And so in some of our projects, some of the smaller projects, we've got a master database, and somebody would work on the master, generate the script, save that script in there, save the master, and then the script would go into the migration, which would then be applied to other databases. So there's always this sort of master that you need to keep in hand. Some of our teams have worked very powerfully with it and very, very successfully, and some teams have dismissed it. I guess it really depends on how you want to work on it. All right. So that's some of the techniques you may want to investigate when you're looking at this. And as a final parting, I'm giving you some awesome information. You get to choose where you want to go. You're going to take the red pill, we're going to take the blue pill. Whichever one you take, you decide your destiny, but I can tell you, if you've listened to me, we're going to go down this route. It's a lot easier. All right. Guys, just to talk about Instruct, as most of you guys know, it's just a series that Kaleidocode have been doing in Durban so that we can raise the awareness of development and development techniques. All these talks are video recorded, so this talk will be on the Instruct channel in about, I think tomorrow, Lucas said. No, it'll be in about a week or 2. Lucas does quite a lot of magic on the back end and does some stuff for us. So they're on the website. We have an Instruct channel inside YouTube. You can go and watch this if you needed more detail, or pop mail to me at chris.tite@cloudcode.co.za. Thank you very much. Great. Cool. I know there were guys that had to jump out early, so I'm not going to be offended if you have to leave now. All right. Question, Tony.
You see, you date timestamp your scripts.
Yes.
And what happens if you find that a script number 3, somebody that's number 5 is together before number 3?
Generally, we don't find we have that problem. Do you guys?
We're in a project where we are generating more bugs than the rest of the world put together. No.
Gosh, Tony, that's
And so we're finding we have exactly that problem.
Okay. How many developers have you got on your team? Sorry, I'm cutting across you.
It's a vendor. They've got about 20 people trying to fix it at the moment.
Okay.
And we are, I think we've got 80 code bugs outstanding, generating them 3 or 4 a day. So our run rate is high. We are finding that there's just so many bugs you can't actually, as you solve some, you find others.
So finding others,
and now there's cache apps and there's other things that you know that you down.
Yes. So you're talking about 2 different types of scripts as well. You're talking about scripts that manage data, and you're also talking about scripts that manage structure.
They both fix bug fixes,
yeah.
They're data fixes.
Yeah.
And some of them might not be database scripts, they might be code scripts.
It sounds like there's also not that much communication between who's fixing bugs and who's fixing.
There's just so many.
There's so many of them.
Thousands and thousands.
Tony, I honestly haven't hit that problem before, but that's.
I love what you're saying. It sounds great.
What you could probably have done here is broken your releases up into small little chunks, run the changes. If they failed, they'll roll back, and then we go. And the only way to be able to do that is to figure out what scripts need to be moved up and down, and then just rename those scripts, pull them out of the source code control, rename them, move them up and down. Yeah, for sure. I would do that to get it because you want to be able to. But you'd be doing that on a development machine, or on your integration machine, or on your QA machine. By the time you get to the live server, that's already flushed out.
You never change the name.
Okay.
I was just picking up on that.
You've seen through me. We do change the name.
Great concept.
We do change the name if we do hit these problems, but it's few and far between. I could see us hitting problems. One of the problems that we were talking to an Australian company and going, they were going to develop at the same time as we were going to develop. So they were going to go to sleep and then we would develop, and then they would wake up and then we would go to sleep and they'd develop. And try thinking about a naming convention or structure for that, and that was going to be a bit of a nightmare. So we would have had to, in that particular case, try and rename those scripts and work them out. I think there are challenges around doing it. Traditionally, generally, I'm quite a stickler for not changing it, but if it is changed, if it needs to be changed, it has to be changed. I mean, we have to be agile. We can't just put up our hands and say it's not going to be changed. Cool. Tony, you can get a beer, or do you want chocolate? Chocolate. Cheers. Andrew.
Chris, so if you're using field migration, you put field migration attribute on there with the date timestamp, that will run that script with that stamp in the version of the table.
Yeah.
Or the additive version of the table. In your DB sync master, if you've just got pure scripts, how do you actually assign those version numbers? Do you have a stored procedure or something that sits with the script? As part of the script, or?
Yeah. So Andrew, essentially, we'll the database, the structure. Let me see if we can try and get into. Yeah. Okay. So we were battling here. So every single sprint is numbered.
Okay.
All right. And then you'll see these are by sort of domain separated concern areas. All right, and then they're grouped together, and we'll just basically put them inside. Well, let's try and find something that's got a little bit more.
Is your tool using the actual file name to determine?
Yeah. So the tool's using the file name here to determine the order in which they run in. So there's all these different parts of the domain that we're putting together, and these are the scripts that we're going to be running, and they're just going in, finding all those guys, and it's slotting them in, and it's interlacing them into the areas that it needs to interlace them, and then it just runs them in the order. And then here's the order. I mean, that's basically the order.
Yeah. We've done a lot of that, but on bigger teams, every now and again you're going to get someone checking in with exactly the same time in terms of down to the same minute. I mean, not often, but
I think generally what we've also tried to do is segregate some of our teams. So we've got these guys working on this side of the system, these guys working on this side of the system. So we do try and plan, although we don't do it intentionally. But we haven't had that. We are really, honestly, and if we do have it, I would just rename the script. Just change it. Yeah.
So if you notice, there's always a story put on after whatever you're in the script. So even if it's the exact same minute, the story then separates the two scripts apart.
Yeah.
So if you're creating two different tables at the exact same time, it doesn't matter.
Yeah. The story is important because it tells people what they're doing, and I get irritated when people don't give me a story. Sorry, quickly. Andrew, do you? Yeah.
Yes, please.
Step fast.
That sounds good.
Good.
Yes, at what point do you roll up your scripts? So moving from, say, version 1.0 to 1.1, do you re-baseline?
So at what point do we roll up? Every end of sprint, move all the way through the system, and that's the new baseline.
So you wanted to come on at 1.0.1 and you failed, right? So you had to go back to 1.0.0 first and then move forward.
That's right.
Okay.
Yeah.
So I want to come on at version 2 because I'm new.
So at version 2...
So I don't want to have to go and start at version 1, do all the iterations until I get to 2.
Yeah.
Although the tool makes it a little easier, it would be...
The tool makes it super easy.
It would be even easier if it rolled up and I said, okay, well, I'm starting at version 2.
For sure. Kev, you're right. It can be done, and what we do have teams doing, if that's the case, if the database is too big to be able to move around and restore, if the database can be moved around and stored easily, then baseline the database, save it, and then from that point becomes the beginning of the sprint. Here's the new database, and here's the new set of scripts. But if you're a developer like me, I hold on to my data. My data is quite sacred because I'm doing a lot of testing and I get to know my data. And if I have a script that changes, so I have to get a new database in place, I get antsy. So it really depends on the team. So, but you can...
So a new member coming onto the team comes in at version 2. I'm saying your existing devs, they're cool.
Yeah.
They've got to version 2 through all the iterations of version 1.
Sure.
But somebody coming in at version 2 kind of only wants to start at version 2. They don't want to have to go back to version 1.
And you're right, you can get the baseline and move it forward. But
so I'm asking how you deal with that.
We'll baseline the database at the end of each sprint, save it up, back it up, have it available on the backup server. You want to know where the database is? There you go. Go and get the latest version. Get the database server. But let me tell you, when we go to live, I don't restore a database. When we go to live, we rerun every single one of those scripts from the beginning all the way through to the end, bring the whole database up. It's completely free version database. It's seen no data before. Yeah. So we get into the habit of doing it. DB Sync Master is another thing which I didn't show you, which is just a command line. Bring it all up, and it just goes and runs all of those things in a sequence. In fact, if you took DB Sync Master up to this level here, it'll find every single script inside the system and run them from beginning to end and bring the whole database up in one swoop. So you could do that as well. Yeah, cool. Yeah? Andrew, another one. Are you collecting beers? Another one here, quickly.
So you have on the slideshow the employee and the user.
Yeah.
So if, for example, the email address, you need it on both, and the user can log in,
Yeah.
but you also need an email address, as well as the employee.
Yeah.
So if you create an is-a relationship, so you have a person, an entity, with the email address,
Yeah.
and then you then got your employee and your user.
Yeah.
How would you do that evolution through the migration. In terms of obviously you have to move data across and the column into this person entity.
The person entity, a database entity?
The person entity is basically a table.
Okay.
So it could have, for example, cell phone number as well.
So you wanted to be able to change the implementation of employee and then be able to move it. So you may have moved it to user, then into employee, now all of a sudden you brought in this concept of an entity.
Yes.
Is that the type of concept you would have done?
Yeah.
But it would have moved over time, so there would have been a few versions before you got to this entity concept.
Okay.
So am I getting your question right?
I guess you could. You could have one where you, if someone was obviously doing the design, and they realize it is a relationship. It's a common field across both. It's an entity, and it's a shared property. So if you had to skip those steps and go straight to that, how would you do the migration for the data specifically, I guess?
So there would be, it is, you'd need to script it. So you'd need the concept of a user as a person and the concept of an employee as a person. So you would need to have, first off, new up a table which was this person entity with the correct structure. And then you would need to start migrating data from the user table into that table, and you'd need to start migrating data.
Does that script also go into?
Yep. And you need to migrate that data and then migrate that data. And when you were happy that that structure had been migrated, you would then need to deprecate the columns on each one of those tables. So drop those items out and then go from there. So that's generally how we would do it. Yeah. Cool. Chocolate. Okay, no more chocolates, guys. Sorry. Cheers. Done.
Fluent migrator, right?
Yes.
You said that you had a problem because you often have to go to DBAs.
Yes.
You can execute some data scripts.
Yes, you can. But have you seen what it looks like?
Yeah,
it's got lots of like single braces, single little quotes. You're right, you can execute the data. Have you ever taken that to a DBA? I try and get a DBA to do this, and it's a little bit of a problem. Take it in Fluent Migrator. You're right, it can be done, but
Chris, you can actually embed a proper SQL script.
Yeah.
Oh, okay.
You
Okay.
just have to mark it as a embedded resource, and it will pull it in and you just run it straight up.
Cool. There you go.
Yeah.
Yeah.
Just
on that as well, do you do any sort of schema comparison between your live database and what was deployed to your staging database? So
only if somebody has told me that the scripts haven't been run. Yes, we've done that a few times. We have to go and compare the schema, and then you pull out tools to be able to verify that the schema is going, and then
you don't just have a check in this tool where you can say, is the schema the same on this database and this database?
in some of the database it's quite large, and you're going to have to document that schema and be able to pull out. Yeah. So you can do it. And we have done it. There are tools to be able to just document the schema from each side, and then you just do a diff merge or whatever it is to find the problems. Yeah. So you can do that. I promise you that when you're running through a process, all of these problems where you're going schema, data, problems, I haven't hit them. I really haven't hit them. Cool. Grant.
Do you have a pattern to deal with test data for this? In putting it into this tool or
Yeah, we did on the last project that we did. We actually had a separate set of scripts which we ran specifically for test data, and we marked them off. You'll see that. Well, you don't see it here, but in the code itself, you'll see migration scripts, and there's a specific thing for migration scripts. And then we created another folder for test scripts, and that would be able to inject test data into the system so that you knew we were working with this particular kind of. So yes, there is a pattern to it. They would run separately to these scripts. So we would run them as this would be migrate the schema and change the data, and then after that we would run the series of test scripts to be able to inject the data that we needed for that particular database. We also, along the same lines, you've got the same problem with configuration. If you, specifically in some of the projects that we've worked on, there's a product A and there's product B, and product A does different things to product B, and it needs to configure via databases, different stored procedures or different reports that it needs to run, and we would also have a configuration setup that would just be, these are the things that need to be able to take your configuration from here to here. Yeah, cool. That's a stupid question, isn't it?
showing that two worlds is that store procedures and views and everything is related. It's not just schema.
Yeah.
So like everything, in fact, store procedures just kind of drop in the It's just nothing there. That's why it's nothing.
Cool. Anybody else got any questions? I've got a question at the back.
I've used a similar sort of way of releasing to databases before on a number of projects. Effectively, the issues I had was around more the if you require a certain index to be there, or an absence of or you could effectively auto-implement as such, but because you're often your staging, testing, integration environments are always out of sync, sometimes you actually only end up realizing on production that you might be out of sync.
Indexes I can understand, but to a degree I don't also understand it that much, because what we would normally do is go through a series of optimizing indexes on the live database and bringing those same indexes back around and running them all the way through so that they get back up to staging, so that our indexes are exactly the same, because we often want to run load tests on those databases, and that's when those indexes are actually going to be critical. So I can understand it. I think the biggest problem that you're going to face on those ones where you're out of sync is because suddenly the system starts slowing down, and somebody goes, whoa, look at that query over there, that's a really bad query. And then they start looking at the index that it's using, and there is no index. And so they create the index on the fly, and then it starts being able to be moved, and then everybody forgets about it. And then the indexes haven't made their way through the system. So what we drum into the guys that we work with is saying, okay, create that thing, because you've got to put the Band-Aid on and make sure that it actually works correctly, but make sure that script is brought into the release and is brought all the way through up until the staging server.
And then also, like I know you said with multiple people committing and all those kind of issues, what we would do is we would actually build an RPM, so you would actually have a static version of it, and then release that through each environment, with Jenkins or whatever your flavor is.
So this is a very, very cool way to do that.
And it worked really well. Like the only issues I had was mainly around ID clashes and whatnot, but I mean you can't get around that any other way.
I think when you're talking about actual live data problems where you've got to move this data to that data and that data to that data, that for me is also moves into that configuration data fixing problem, and sometimes those scripts don't run on your QA server because you don't have employee number 1536 because your database never got that high. And you needed to make that change, but you're right. So those are definitely separated into a different pool and handled in a different way. What I need to point out is that I'm not a DBA, so I don't do lots of those DBA problems. I don't have to solve a lot of those DBA problems, and so these are just particularly from a developer's point of view. And so it might, to me, look very trivial, But I can imagine that it does become quite difficult, especially when you're trying to manage specific pieces of data on a live server. Yeah?
Yes, I'm like a lot of shots.
All right, have we got any more questions? Tony, one more.
You see the change you make within inside a transaction.
Yes.
But if you've got to delete 6 million rows out of the table, is it not often easier just to do that outside of the transaction?
Yeah, Tony, I think you also, I haven't really had to delete that many rows out of a table. I mean, that's quite a large amount of data, and that's more data maintenance for me than it would be the restructuring of my data, because I would normally just be moving a column from one place to another, moving things around, and really just trying to make sure that the system's moving in that way. But you're right. If we're just going to start doing maintenance things, then we need to manage it in a slightly different fashion. Yeah. Okay. Any more questions? No more. Andrew, no one.
I was wondering, when you said you sort of back up your live database and then use it as a baseline, do you start off with a baseline database which is just scripts with no data?
You can start with either, so you could script it, but I think scripts with no data is quite difficult because often there's metadata inside the system. So baselining a system can sometimes be quite difficult. So what we normally do is just script the database with everything in it and then just pull out the pieces that we know we don't need anymore. Does that make sense? Or go into the table and truncate or drop large amounts of data from the live system and then build it up from there. I think there's a number of ways to do it. It's not easy. I'm not going to do the hand wave and then it's just going to be working. I think there's a fair amount of effort to getting a baseline database started. And yeah, cool. Grant, another one.
Yeah, it's a little bit off topic of this, but regarding testing of your systems that are heavily database dependent, do you test against sort of the black box interface and that drives into the database like all the way through? And if so, do you run these scripts to purge the database and seed it with known test data, or how do you manage the repeatability of those kinds of things?
It's been a bit of a problem, and you know it's something that we are still battling with, but we're generally doing integration testing. And so what we would do is we would have a series of scripts which would be able to automate through the UI or whatever, just do a series of things. And then at the end of the thing, we would just tear down the database and bring it back up again, and then just rerun those scripts. But it's normally black box integration testing, full integration from the UI all the way down to the other side.
Tear the whole database. I mean, that's obviously ideal.
Yeah.
You tear the database.
In certain cases, you can't do that. I mean, in certain cases, you've got a 200 gig database or a 400 gig database, and you can't tear that down. It takes 9 hours to rebuild the database, or depending on what size server you've got. I mean, it's not that practical. In which case you would probably have to figure out a strategy to clean out or purge that data that you would be putting in.
So the read-only tests are fine, but data tests.
So there's a pattern that I always use on every single one of my tables. I always put a row create date, always put a last update date, and I always put a row version number on my data. And if you open up any one of my databases, you will find those things in there, and they're there for that particular reason. So I can go and purge out bad data. It was always because somebody always said to me, "Oh, when was that row added?" And I never had an answer for them as a junior developer. Or when last did that record get updated? I just want to know that, you know. And I didn't have an answer for them as a junior developer. So I started putting those tables on. But that's where those types of things start to become handy. Travis.
You mentioned integration testing, so I take it you don't take much of a TDD approach to database work.
I'd like to, but we don't. No, it is quite difficult. So I'm trying to think. In the last project that we did, it was fairly TDD, but there are very strong interfaces, and you're testing up to one particular interface. And then once we were getting down to the database, then it felt like it wasn't any more unit testing, it was more integration testing. Even if you were just doing a small repository call to a database and back again, that's where we could, and in certain projects we have used T-SQL-T to be able to return some of that data. But it also depends on what you're using to get data in and out of your system. So if you're using stored procedures, then T-SQL-T is pretty powerful. But if you're just using an ORM, and if you're using entity framework, need I say more? Then it all becomes very, very difficult. Yeah, and that's where once you start getting into some of the more mainstream tools that don't support TDD that well, then integration testing is pretty much your only salvation in terms of doing testing. Yeah.
Yeah.
Oh, he does. Thank you, Zoe.
There's something balanced there.
All right, no more beers. Does that mean no more questions? No more questions. Well, I need to congratulate you guys, because I think at every Instruct that I've gone to, there's always been a whole heap of beers that go home with me. And I think I bought 6 beers tonight, and we're not taking any home. I normally buy 6. So
6 beers and 2 questions.
Yeah, very, very good. Very good. Great. Thanks for your time, guys. When's it going on GitHub? I don't know. Rory and I need to discuss it. We need to take certain references to our company's details out, and it'll probably be in the next week or 2, I guess. You know, we'll get Devon, he offered this afternoon. Can you see the surprise on his face? He didn't even know. No, we'll get it up, I guess, in the next 2 weeks. I'll keep in touch with Stephen, and we can let you know when that's out, and then also let you know when the video's on YouTube. Cool. Guys, thanks very much. Cheers.